It has been raining lately, so it's kind of boring inside the house. So I just want to show how the house is wired for 110. So if you look at the transformer, uh, you have the 7 kilovolt coming in to the side of the transformer, and then these two or three conductors or posts with the center tap. It's 110 center 110. So the two outside ones, if you measure them, it's actually they're 180 out of phase. So if you measure up with a meter, because they're 180 out of phase, then when you measure them, they are actually, so peak to peak. While it's going to peak, it's positive, for example, and the other side is negative. So measure them to 20 volts. And then the wires are then connected into the meter. So from the meter you have the two black wires. The difference between the two is 220, because this is 110, this is 110. If you measure these two together, it would be 220. Now to have 110, you have the center tap, which goes into the warehouse. So the wires then travel along for about 75 meters into the warehouse along the ceiling. The cables or conductors, they actually come in pairs. You have the bare and the insulated ones. I can't remember the price, but for the pair, 75 meters is around 5,000 peso. So this is number 4. I would suggest never to use number 6. They are cheap. They are prone to be on fire. So rather than going on cheap, go on safety. It's worth it. So as you can see, the two black wires and the conductor, the bare conductor, then are connected, and to my main panel. The yellow wire is the middle or bare conductor, and then the two outside wires are the 110, 110. As you can see from the fuse panel, I have labeled 110, 110 VAC to ensure that I know the rest are 220, and I can tell that the red marker is to tell me it's 110. So I know which fuse to turn on or off, depending on what I'm supposed to do, or depending on what I'm doing at the moment. Now the fuse panel, unfortunately the bus bar was cut off unnecessarily, but oh well. But just to explain, so you have the 110, 110 combined, they're 220. The bus bar is connected to center tap transformer, and so this is for the dryer actually. So if you look, this is the dryer, and I have the dryer here. So the dryer takes 32 amps. If you use 16 amps, which I did originally, it just keeps tripping if you use a dryer. So I have 16 amps, 16 amps, and 16 amps. Now to have 110, this is 110. Only one wire goes into the fuse, and the return is connected to the bus bar, as you can see. So if you trace it, this is 110. So the other side is unused. I haven't decided to connect my the rest of the wiring yet. Later on, if I have time. So this is how you. This is how I did 110 outlet. So if you ever wanting to do this, just show them this video to say, okay, I want 110 from a 110 main transformer up the post, and they should be able to follow what I did. So 220, 110 with respect to bus bar, and 110 again with respect to bus bar. So if I were to measure these two, it would be 220, but since I only need 110, I connected the black wire live and the return to the bus bar to give me 110. So good luck if you want to do this. Now also, unfortunately, because I didn't have this machine here, came from Canada, and I accidentally plugged it into a 220 outlet, and now this is basically a doorstop. It's useless. I checked the resistance of the winding. It's in the mega ohms, so basically the winding is burnt. I checked the inside of the motor to see if I can rework it, but I think it's just too much work. I don't know if I can find somebody to actually work it out, rewire, will become useful. But honestly, if you plan on sending equipment from North America, be prepared to have them fried by accident.